All right, so the vocabulary of algebra, and I'm not really that worried that you know the definitions of words when I say vocabulary, but that you're able to identify things in an equation or in an expression. So we're going to start kind of simple. In algebra, when we have a number like 3, this is called a constant or a constant term. So for example, when I say 3x cubed plus 5x squared plus 2x plus 7, we would say 7 is our constant. And a lot of times you'll see constants represented by the letter C when people write out algebraic formulas. And that's just because C is the first letter of constant. So when you see the standard form of the quadratic equation, ax squared plus bx plus c, c represents a constant term in that equation. Okay, and this is something that you'll see fairly soon. Quadratic equations. C is going to represent a constant term, which means that it's a number. It's like, it could be, it could be like 2790 thirds, but it's a number of some kind.
So,
yeah.
So a constant is just a number without a variable?
Right. Yeah.
But can it also have an exponent? Could it be like 7 squared?
Uh-huh.
Okay.
Because that's still a number.
Yeah, because we solved it.
Right. So 7 squared is a constant. Right? Because it is 49. It just means that we have no variables. And in algebra, variables are typically x's and y's. Okay, so the next thing, x, y, these are variables. Right? So in our example, 3x cubed plus 5x squared plus 2x plus 7, our variables are all of these, are x's. And when you see an equation written out, like y equals mx plus b, typically letters like x, y, and z and w are going to represent variables when equations are written out like this, when formulas are written out like this. So in this is called the slope-intercept form. M would be a number, right? And B would be a constant. So when we use x's, y's, z's, and w's, we're usually talking about variables to represent it. Now when we're talking about an actual expression, then anything that is a letter is a variable. So if I wrote 3m squared plus 7m, in this case I've used m as my variable. So I can do that, it's totally fine. You can use any letter, but convention says that when you write formulas, letters towards the end of the alphabet represent variables in those formulas. And then towards the beginning and middle are usually going to represent constants or numbers. Okay. I typically remember that because the middle of the alphabet, what often gets used is N, which is like number, And at the beginning, we use letters around C, like constant, right? So that just kind of helps me to remember what those things mean. A coefficient. So when we have 3x to the fourth, 3 is called a coefficient. This is a number that is multiplied by. So there's a lot of ways to write this. In algebra, you always see it written like this, but it could be written like this: 3 times x to the fourth, or 3x to the fourth, or 3. All of these mean the same thing, right? These all are equal. And so if we look at an equation, like y equals ax squared plus bx plus c, now that we know that x's and y's are usually used to represent variables, we could say that a is the coefficient on x squared. And we could say that b is the coefficient on x. And it's important to remember that variables with different degrees, so x squared versus x to the first, have to actually be treated as separate variables in an equation, right? Because I can't combine x squared and x in this way. So what do we get when we start? Oh, actually, there's one more thing I want to talk about. So if we look at something like 8x to the third, the 3, this is called either our exponent or the degree of the equation. Okay. I remember it's called degrees because when you look at 34 degrees, the degrees symbol goes in like that same place there, right? So that just kind of helps me remember. When people say, what degree is this equation? Oh, they're talking about that number, right, and how high it is. Okay. So in this example, 2 is our exponent. I don't want to go too much into that part of this today. But there's a lot more that we could say about exponents. So now we have what's called, what is this? This is a term. Yeah, when we talk about a term, what we mean is coefficients and variables multiplied together. The important word is multiply. Right? As long as we're multiplying, we have a term. But there is an exception to that, or it's not really an exception, but it's something that's going to look a little bit weird. What if I have 3x times 2x plus 1? When you see parentheses like this, you want to kind of think of that as one thing. So within the parentheses, within these parentheses we have two terms, 2x and 1. But if we look at this whole thing together as a whole, this is one term. Right? Because this 3x, this chunk, is being multiplied by this chunk, whatever that equals together. So parentheses can form factors in a term. Right? So this is one term. Yeah.
What if it's like 4 times 9 and you actually have the multiplication symbol? Would it be 2 terms?
That's still one term. Yeah, so 4 times 9,
Oh yeah.
this is one term. Because they're being multiplied together. Okay. You could have, you know,
But you can solve.
if you look at like that problem we were just doing, it was something like this from the homework, right? Something like this. This is all one term, right? This entire thing is one term. Because all we're doing is multiplying. Exponents are multiplication, right? This is saying multiply this 4 times. So this whole thing is one term. Actually, even including the denominator.
So fractions can be part of
So that's like one term. So a fraction is a part of a term. So 3/4 x, this is one term. And as I'm doing these examples, you might be writing something in your notes, like, you know, exponents can be part of a term. Fractions can be part of a term. I'm just trying to show you examples of this. I think one of the easiest mistakes to make in algebra is when you're distributing or when you're factoring and you forget what your term is. Okay? So really understanding terms and like the concept behind this, that a term is things that are multiplied together, is super important. It's going to help you with a lot of different properties and a lot of different procedures that we'll learn. Yeah.
So if there was like 4 minus 9, it wouldn't be a term.
Right.
It has to do that.
So now we're going to talk about the last thing is, not the last thing actually, the next level of complexity. So now we have a term, right, plus something else. And maybe plus one more thing, a constant. This is called an expression. An expression is the sum or difference of terms. And one thing that I'm kind of hoping you guys are picking up on, we talked about, you know, division being part of one term. And I'm saying some difference in parentheses. In algebra, multiplication is division, right? Division is multiplication. And subtraction is addition. So if I say 3 minus 7, that's the same thing as 3 plus negative 7. So subtraction is actually just addition. That's all it is. And if I say 3 divided by 2, this is actually, so my message here was subtraction is addition. This is just a side note. And my message here is 3 divided by 2 is 3 times 1/2. So division is multiplication.
Could it be vice versa, like multiplication is addition?
You could kind of think of it that way. It doesn't work quite as well. Because if I say like 3 times 4, what are you dividing? Well, I guess you could say you're doing 3 divided by 1/4. But that looks a lot different to me. I don't know. There's something that's more complicated about that. So usually we would say division is a form of multiplication. And we wouldn't say it the other way around. And subtraction is a form of addition. We wouldn't necessarily say it the other way around. Anyway, that's just a little side note. Because as I'm defining these things, I'm kind of using those interchangeably. So an expression is the sum of terms. And so this would be an example of an expression. Our terms, if we were to list them out, we have 3 terms. And they are 8x squared, 7x, and 3. Now, what's important is that and the reason I put this in parentheses is when we have a difference, we have to kind of remember something. So if I have here's another example, 7x squared minus 3x minus 1. This is an expression with 3 terms, but what are our 3 terms? The first term is 7x squared. The second term is all of this. It has to include that negative. We can't separate this term from the negative that's in front of it. So remember, this is really 7x squared plus negative 3x. And so this is what's being added, is negative 3x. So our term is negative 3x. And then the third term is minus 1.
So you only do that for subtraction, you have to add this side.
Yeah, so when you're subtracting, you just have to remember that negative is part of your term. It goes with your term. Right? Okay. And expressions can sometimes be simplified. So if I gave you an expression and I said simplify, and it was something like 2x minus 3 minus x plus 5, that's good enough. We can simplify this by grouping our like terms together. So we have 2x and negative x. Don't forget that negative. So we have 2x minus x. And then we have negative 3 and positive 5. Those are our constant terms. So I'm going to write it like this, plus 5 minus 3. And I can group this into 2x minus x is x. 5 minus 3 is 2. So this would be the simplified version of this expression. We can never solve expressions, though, because there's no equal sign. Right? So I can't say solve x plus 2. That just doesn't work. There's nothing to solve it for. Sometimes what you will see is evaluate when x equals 3, or something like that. Right? So if we were to evaluate this when x equals 3, we just plug a 3 in for x. So we have 3 plus 2, that's just 5. So we can simplify expressions and we can evaluate expressions. We can't solve them. One last thing. Equations. As soon as we get an equal sign, this is now an equation. Okay? So it is expressions united by an equal sign. Right? Equality. Equation. Equal sign. Right? So 2x equals 1. That's an equation. It has two expressions in it. This is an expression, and this is an expression. Each of these expressions has one term. This term is a constant. This term has a variable and a coefficient of 2. And so you see, as we build these things up, they all build on each other. And with equations, you can solve. So I could say solve 2x equals 1. And I would just divide both sides by 2. And I would have x equals 1. Okay. There's a lot more that you can do with equations. You don't have to always solve them. And that's kind of where we're moving towards. Often you can graph equations or factor equations